Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X published on November 20th, 2025, about 5 days ago. It shows that a shockingly simple baseline, which ignores almost all temporal structure, can reach about 98.3% accuracy on long video recall, and that a leading spatial supersensing method collapses when the videos are lightly perturbed. The paper is titled, Solving Spatial Supersensing Without Spatial Supersensing. And as we will see later, the results raise serious questions about what current video world model benchmarks really measure. Also, the authors shared a GitHub repo for this work. In there, listeners will find the full Python and notebook code for the no-sense baseline on the VSR benchmark and the VSC repeat sanity tests, along with scripts to reproduce all reported plots and comprehensive experimental log files for detailed reproducibility and inspection. Alright, the previous segment mentioned code for reproducing results, and Figure 1 now shows why those results matter. The left panel reports that the no-sense baseline stays near 100% accuracy on the recall task, even as video length grows from 10 minutes to 4 hours, far above all Cambrian and Gemini models. The right panel shows the mean relative accuracy on the counting task collapses from about 42% to 0 once videos are simply repeated, revealing a strong shortcut instead of genuine spatial understanding. Well, Figure 2 explains how no-sense works, despite being so simple. The system encodes each video frame with a clip vision encoder and encodes the question text with a clip text encoder, then compares them using cosine similarity. The method streams frames at 1 frame per second and only keeps the 4 most similar frames, so it never stores a full video history. Finally, it compares those top frames against the answer options and aggregates similarities to pick the final answer. Alright, the previous figure laid out the no-sense pipeline, and Figure 3 now quantifies how far that simplicity goes. The left panel shows that no-sense stays at roughly 95 to 100% accuracy from 10 minutes up to 4 hours, while both Cambrian variants and Gemini models steadily degrade. The right panel reports that no-sense uses only a few gigabytes of memory, whereas Cambrian with memory blows past a 140 gigabyte limit on longer videos. Okay, the previous figure highlighted raw performance, and Table 1 now tests how fragile that performance is. The left table reports that no-sense keeps around 97 to 98% accuracy even when the method uses raw questions or a single basic prompt template. The right plot compares different encoders and shows that even weaker clip and siglip variants still sit far above Cambrian with memory across video durations. This consistency suggests that success on the recall task does not depend on careful prompt tuning or one special vision encoder. Well, Table 1 focused on recall robustness, and Figure 4 now illustrates the key sanity check for counting. The left strip shows an original versus SC video, where each stitched room is unique and the question asks how many different chairs appear. The right strip repeats that same video several times, marked by the N multiplier. The blue banner emphasizes that the true number of unique chairs should stay constant, so any model whose count grows with repeats is clearly following a shortcut. So, Figure 5 turns that visual sanity check into hard numbers. The left panel shows mean relative accuracy for Cambrian on the original counting task, staying around 42%, while accuracy on versus SC repeat plunges to 0 by 60 minutes as repeats increase. The right panel plots predicted counts, which grow almost perfectly linearly with the number of repeats, far above the fixed ground truth star. This pattern means the model is effectively counting segments or rooms, not tracking a stable set of unique objects. Alright, the previous figure exposed clear shortcut behavior, and this figure presents the Cambrian-S authors' written response. The authors argue that strong no-sense performance does not automatically mean the recall benchmark is flawed, because benchmarks can be solved in unintended ways. They frame versus SR as a needle in a haystack task, and say their goal is to evaluate long context attention, not full spatial understanding. They also acknowledge that repeated scenes in the counting task were a known limitation and promise to address this in future versions. So the big message is that simple retrieval-style baselines can nearly solve long video recall, and that tailored spatial supersensing pipelines may lean heavily on dataset shortcuts instead of genuine spatial understanding. The broader implication is clear. We need tougher, better stress-tested benchmarks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.